Hello, in this video I will demonstrate how to measure a coating thickness. In this particular case it's a ceramic coating and this one is a little bit special because it's very uneven. So we need to measure many different places. So assume in this case the direction given to us is to measure 10 times on 10 different fields of views. That is in total 100 times. Just to get started, one simple way of doing this is just to do it manually like this. And let's do that for 100 times. So what I will do is I will do this measurement in 3 different ways. First, I will do it interactively, completely interactive, which is very easy. It just takes some time to do it. Then I will do it with traditional image analysis. And that might be a little bit of a challenge because the image is very dirty in this case. And then finally, I will do it using AI. And we will see the differences. But let's get started with doing this manually. So 10 times per field of view. Well, was one other thing I want to mention. When doing measurements like this, measuring the mean thickness is not everything. That only tells you the mean. But in this case, we want to know how much it varies between the max and min, or actually around the mean value, and that is a standard deviation. So in this we will see how that works out. So let's get started. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, before I continue, there is one obvious problem here, and that is the user bias. You can actually pick things that are better or worse intentionally or unintentionally without actually knowing it. But I spread them fairly even here and try to avoid my personal bias here. So now I just need to go ahead and do this 9 more times. I will speed up the video so I will not bore you to death while doing this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, I actually changed my mind. I'm just gonna do this 6 times. So after 6 measurements, I have a mean value of 121. And we have a standard deviation of 18 plus 5. And that means the values are 121 plus minus 18 or 19, whatever we like. So we've done our measurements. We can actually look at the measurements and see how they are spread. There, one very big there, one outlier, but it looks fine. So this method works. Doing it manually, it works. It just takes some time. Let's go to the second way of doing it, and that is using traditional image analysis. So in this case, let's go back to the beginning first. So we actually measure the same field of views. So in this case, we use traditional image analysis. I will delete this, but I took a note of the measurements. So when running this as a script, the process is as follows. You freeze the image, and then we do some thresholding. And we need to do that because the intensity of illumination varies depending on sample preparation and actually on different field of view. So we have the ability to fine adjust this detected area. Once we've done that, we can move on, and we try to wash it or clean it up as much as possible. So we remove noise and we fill holes. Yeah, so now it looks better. We still have one big problem here, but let's ignore that for now. And we continue with the actual measurement, and that is done by placing these overlaid orange bars. I make them a bit wider for visibility so we can see them. And then I actually take wherever they intersect and I convert it to red just to make it easier to see them. I like red in favor of orange. So now we have these bars automatically detected, but we do have a small issue here and definitely bigger issues here. So I have added 2 manual steps, and the first one is actually allowing us to fill in small gaps in these bars, but there is no such a gap now. And the second step allows us to remove erroneously detected bars. So finally we measure the length of the bars. Okay, so for one reason there is one short bar somewhere in the screen. I actually can't see it. So that is of course a problem right now. We do have one measurement that is incorrect. But let's forget about that one for now, because now I want to do this 6 times. So let's do it one time the way it's intended to be used. So 1 threshold, superimpose these bar lines, and now we need to fill in the gaps here. Yeah, maybe here, but it looks fine. And now we need to erase this one, and we have done. And yeah, that's weird. I can't see where. Okay, it's one here. One is here. So I have to redo it. Delete. So once you got a hang of it, I think this will be faster. So small fix there. Erase this one, continue. Yeah, we got 10 measurements. Let's move on to the next field of view. Here we go. Give it some focus. Run the script. Thresholding is good. Maybe not here. I think good. Yeah, so that's 2 for you. This one, the third. Run script. No. But this one, we erase it. Yeah, so I will start to see it. So that's 3, 4. And I will place this. I see. Oh. Okay, I have done 60 measurements, and the mean value this time is 132, and the standard deviation is 22. And that is more or less the same values as for the other method. I don't know which one is quicker of these 2 methods. If the sample were cleaner, I'm pretty sure this second alternative would be faster, but barely faster. Okay, so with that said, it depends on the quality of the image, if automated image analysis is quicker. Okay, now we've done it manually and with the traditional image analysis. Let's move on and try to do the same thing using AI for segmentation rather than using thresholding. So I've loaded another script now, and we can go through it step by step. So first step is to freeze the image again, of course. And then we do the segmentation. As you can see, it's perfect, I would say. More or less perfect. But anyway, I do add some traditional fill holes and clear objects just in case, but It's very rarely needed. And then I superimpose these orange lines, same strategies as previous example, and I make them a little bit wider, and then I measure the bars. So that's simply the script. It's very, very simple. So let's do this 6 times. So let's delete all the old measurements. I think I'm already at this. No, I'm not. I'm starting to recognize this sample now. So let's start here, same place where we started the other ones. And run it 6 times. 1. Perfect. Move. Run. 2 times. 3 times. 4 times. 5 times. 6 times. Okay, I didn't even have to speed up the video here. It went so quick. And we can also see we have a ballpark the same results. 127, 18.45, so literally the same. So the values are good. I believe they're even better than the manual and the ones with image analysis, traditional image analysis. But this proves how AI can make this work so much more efficient. The first measurement, if doing 10, I would guess it's about 2 minutes time. And for automated image analysis, a little bit depending on the image quality, is probably 1 minute, while this probably took around 10 or 15 seconds. So big difference. That was actually everything I wanted to demonstrate in this video. Hope you liked it. Thank you. Bye bye.